Okay, this is next paper, paper number 4, and the year May-June 2019. Now move to question number 1. The question is, 2 point masses are separated by the distance s in the vacuum. Force is F, one mass capital M, other small m, and we have to write the force. So F is equal to G small m capital M over x square according to Newton's law of gravitation. And we have to write about the other symbol used, where G is the universal gravitational constant. Next part is, these are the two masses. Look, the arc length after the twist is 1.2 millimeter. So millimeter mean 10 power minus 3 meter. And this radius is 8 centimeter. Centimeter mean 10 power minus 2 meter. And the part of the question is, we have to calculate the angle. So look, formula is L is equal to R theta, or you can write S is equal to R theta. So theta is L over R. This length of the arc is 1.2 10 power minus 3. Radius is 8 in 10 power minus 2. So the angle will be 1.2 10 power minus 2. It's proved. Next part is T is equal to this turning effect. Torque is equal to 9.3 times 10 power minus 10 into beta. So beta is the angle. So angle is calculated. So multiply these two. So answer will be 1.4 10 power minus 11 Newton meter. Next, the distance between S and L given is 6. One of the mass is 7.5, other 1.3, and we have to calculate the value of the G. Look, torque is F into D. Torque is calculated. D is given. So force F is calculated. 1.7 10 power minus 10. Now F is equal to capital G, capital M, small m, or x square. So G can be written as F x square over capital M, small m. So this is F value. This is the distance between S and L, its square, divided by small mass, large mass. So the answer will be 6.4 into 10 power minus 11. This approximately, which is close to the actual value. Now the next question, next part is, suggest why the total force between the sphere may not be equal to the force calculated using Newton's law. Actually, this Newton's law of gravitation is valid for the point masses, so these spheres are not point masses. This is the answer. Move to question number 2. First law of thermodynamics, delta U is equal to Q plus W. So the question is state for the system what is meant by plus Q. So heat energy supplied to the system. Plus W, external work done on the system. State what is represented by negative delta U. So it is decrease in the internal energy. Now, next part. B part of this question. Look at this point, pressure given, volume given, and temperature given. Then from A to B, volume decreases. So compression, volume, pressure, and new temperature given. Then B to C, at the constant volume, pressure decreases. And then C to A, constant pressure, volume increases. So all values are given. Look, from A to B, amount of the work done is 480. And from B to C, how much energy is supplied, is transferred? 1100 joule. And then C to A, look, work is done by the gas. Now the question is, state and explain the total change in the internal energy of the gas for one complete cycle. No change in the internal energy because no change in the temperature and state. So no change in temperature, no change in state because the final temperature, final state is same, so no change in internal energy. Next question is calculate the work done on the gas from C to A. So area under the graph is equal to W P times delta V, pressure there, and this is the difference of the volume. So the answer is minus 240 because work is done by the gas, so it must be minus due to expansion of the gas. Next is complete the figure for the change from A to B, B to C, C to A. Look, Q plus W is delta U, it's given. So from A to B, no heat supplied, it's given in the statement. Work done is 480, it's given. And delta U is the sum of these two, this is the answer. Now B to C, so this is actually energy taken out from the system. So it's minus 1100, it's given. No change in the volume, so work is 0. So sum of these two is this. Now for this one, last C to A, total delta U is 0. So sum of all change of the U's must be 0. So in the first, it's 480. In the second, it's minus 1100. And the third is suppose unknown. So X is 620. And the work done is here 240. So this plus this is this. So 620 and 240 difference is 860. So this is the answer for this. Now move to question number 3. This is about simple harmonic motion. This is the graph for the length and time. On one time at which the mass is moving at the maximum speed. So maximum speed is where the gradient is maximum. So look, these are the points 1, 2, 3, 4, and 5. You can write any value. For example, first it's 0.1 second. Next, one time at which the spring has a maximum elastic potential energy. So maximum potential energy where the length is maximum. So 1, 2, and 3. Write any one, suppose the first 0 second. Next, from this, we have to calculate the angular speed, angular frequency, omega 2 pi over t. So 2 into pi value divided by from the graph. Time period is 0.4. So it's 15.7, approximately 16. Then maximum speed, V naught is equal to X naught omega. So X naught mean maximum displacement. Amplitude is 2.5 10 power minus 2. Omega calculated 15.7. So 0.39. And the magnitude of the maximum acceleration, X naught value, omega value is square. So the answer is 6.2. Next part. The question is, the mass M is now suspended from the two spring, each identical as shown in the figure. Look, time period is equal to 2 pi under root M over K. And in parallel combination, spring constant increases. So when spring constant increases, time period decreases. This is the answer for this. Now, the next question is question number 4. State what is meant by specific acoustic impedance. So it is the product of density of the medium and speed of sound in that medium. So Z is equal to Z is equal to density multiplied by volume. Look, in this question, we have to show that IT over I naught, transmitted intensity over original incident intensity, depends on the relative magnitude of ZA and ZB. Look, incident intensity is reflected plus transmitted when I naught is divided by both. So it becomes IT over I naught. Look, which is written here. So it becomes 1 minus I over I naught. This IR over I naught is actually alpha. So we can write 1 minus alpha, and the alpha reflection coefficient depends on these two, ZA and ZB. So definitely this ratio also depends on ZA and ZB. Next is the linear absorption coefficient is 23, and we have to calculate the thickness X. Look, IT over I naught is equal to e power minus mu X, and this fraction is given here 34%, so 0.34 e power minus 23 into X. X is 4.7 centimeter. For meters, we will divide it by 100, so this answer. Now the next question number 5, we have to write about the attenuation. Loss of the signal power during the transmission is called attenuation, and the noise, unwanted power superposed, added in the signal during transmission is called noise. Next, calculate the attenuation per unit length. Look, attenuation is equal to 10 times log power input over output. So 10 times input power, output power. Answer is 125, but we have to calculate per unit length. So 125 divided by length 52 kilometer. So this becomes 2.4 decibels per kilometer. Next, we have to calculate the power from the amplifier. So gain is equal to 10 times log of power out over power in. So 115 is equal to 10 times log power required divided by input power. So the answer is 2.5 into 10 power minus 4. Now, the output power of the optical fiber becomes the input power for the amplifier. This is the main point. Okay, next is question number 6. State what is meant by the electric potential. Work done per unit positive charge to move it from infinity to a point in the electric field is called electric potential. And then here we have to draw the graph. Look at zero distance. Here the maximum potential, and gradually it decreases, and then finally at this point it becomes 0. So this is the graph with negative constant gradient. Okay, now the C part is, these are the two charges, positive charges. We have to draw the graph for their potential. Both are positive. So at the surface, potential is maximum, and at the back it's also maximum. Again, at the surface, it's maximum positive and constant. Now, the sum of these two at this middle point decreases but not becomes 0. So it is curve, and at this point has the minimum value because V is equal to 1 over 4 pi epsilon naught Q divided by D. So inversely proportional, so that's why it's a curve. Next question is question number 7. Use band theory to explain why the resistance of the intrinsic semiconductor decreases as the temperature rises. Look, energy of the electron in the valence band increases with temperature. Electron crosses the forbidden band and enter the conduction band. Holes are produced in the conduction band, right? And both holes and the electrons are charge carriers. More charge carriers increases the number density of the charges, hence the resistance decreases. So next part, this is the resistance and temperature graph for the thermistor. And question is, determine to two significant figure the change in potential difference between A and B. Look at 10 degrees Celsius from the graph. Resistance of thermistor is 2.55 kilo ohm. So Vx, Rx over Rx plus Ry into EMF, potential divided by formula. V is equal to 2.55 divided by 2.55 plus 12, other resistor, and EMF 9, it's 1.58, but we have to calculate the difference. So 1.58 minus 1 is 0.5. Look, it's given here that the terminal potential first is 1. Now we have to calculate the difference. So 1.58 minus 1, so this is 0.58 in two significant figure. Next, the temperature of thermistor changes from 25 to 10 at constant rate. State two reasons why the potential from A to B does not change at the constant rate. Number 1, the change in resistance with temperature is not uniform, is not linear. And number 2, the change of the potential with the change of resistance is also not linear. So these are the two reasons. Now question number 8. This is a region of the magnetic field with flux density given. This is speed, angle is 30. And first we have to calculate the velocity normal component. Normal means the perpendicular, so V is equal to V sine theta, 3.4 10 power 7 into sine 30. So this is the answer. Then we have to calculate the radius. So magnetic force is converted into centripetal force on the magnetic field. So BQV sine theta, mv square over r. So r is equal to mv over bq, m mass of the electron, v speed component, b given, and charge of the electron. So answer is 0.030. State the magnitude of the force, if any, on the electron in the magnetic field due to the component of the velocity along the direction of the field. So horizontally, angle is 0, sine 0, 0. So force must be 0. And next part is use the information from A and B to describe the resultant path. Look, magnetic force is converted into centripetal force. So path of the electron is circular, which is also called helix path. Next, question number 9. Look, here The relay is connected to the output of the op-amp circuit so that the lamp may be switched on or off. Complete this. So first we have to connect here and here this coil, and then we have to connect a switch here. This switch leaf must be of the iron because iron is a good magnetic material, so it will be attracted to make the switch on. Next, state and explain whether the output of the op-amp positive or negative. Look, for this diode to be forward biased, this output must be negative. So V out must be negative to make the diode forward biased. Next, state the device that could be used so that the circuit indicates the change in the bending of the rod, mean stress, strain. So it's strain gauge. And the level of the daylight, definitely the LDR, light dependent resistor. And the next question is question number 10. State Faraday's law of electromagnetic induction. Induced EMF is directly proportional to rate of change of magnetic flux linkage. Next, this is a transformer. Explain why when there is alternating current in the primary coil, there is a current in the load resistor. Look, electric current in the primary coil give rise to the magnetic flux, which is changing due to change of the polarity of the current. Changing magnetic flux is cut by the secondary coil, and according to Faraday's law of electromagnetic induction, when the flux is cut, EMF is induced in it. Next, this EMF is given, induced. This is the peak value, V0, 220. Suppose RMS value, because RMS value is required, so we will convert it first RMS value. Either use RMS both or use peak both. So RMS, V0 over under root 2, it becomes 155.6. So number of the secondary over number of the primary, voltage of the secondary, voltage of the primary. So 450 divided by 2, 700 turns. Vs required and Vp is this. So the answer is 26. Next is question number 11. State what is meant by a photon. It's a particle of light, packet of energy, or quanta of energy. It is electromagnetic in nature. And next, we have to calculate the wavelength of the photon. Look, E is equal to hf, hc over lambda. So this is h, the speed of light, and this energy converted into the mega electron volt to joule. So 1.18 to 1.6 in 10 power minus 13. So this is the answer. Show that the momentum of the photon. Look, momentum P is equal to h over lambda, h and lambda we have calculated. So this answer is shown. Now use the information to determine the recoil speed of the cobalt nucleus when gamma photon is emitted. Law of conservation of momentum, initial momentum 0, m1 v1, m2 v2. Due to recoil, one direction will be negative. So we can write m1 v1, m2 v2. m1 is this, it's v required, m2 this, and its whole momentum is already given here, so it's the product of MB. So V is 6.3 into 10 power 3. Next, question number 12. State what is meant by the binding energy of the nucleus. So energy required by the nucleus to split, to break itself completely into its individual nucleons up to infinity. This data is given. Calculate the binding energy of the nucleus of the lanthanum. Look, change of the mass. This is the nucleus mass minus the total mass of its individual nucleons. Number of the neutrons, 144 minus 57, so 84. So 57 is the number of proton multiplied by its mass plus neutron 84 its mass. So the difference is 1.244 U. U is atomic mass unit. So now E is equal to mc square. So m is 1.224 and this is a U value. C value, so the answer is 1.9, 10 power minus 11. Next part is nucleus. La57144 has a half-life this, and its radioactive source this, its activity is A0. Calculate for the time activity 0.40 A0. Look, A is equal to A0 E minus lambda T. So A over A0. e power minus lambda. 0.693 divided by half-life times t. So after calculation, A over A naught ratio is given 0.4. The answer is 5.2. Next, suggest why total activity of the radioactive source measured at the time calculated may be greater than this. Look, when alpha beta is emitted from the radioactive nucleus, it is converted into another nucleus. That daughter nucleus may be radioactive and will emit some radiation. So definitely then the radiations will be greater in number than the calculated. So this is the paper. Okay.